London Gateway 2.0 will not only create a port with one of the highest container throughput of any in the UK, but provide DP World with the most advanced deep-sea container port in the world. This project represents the first step of Novum Engineering's vision for the future of freight transport around the globe. It is a time of great innovation. So far, the 21st century has seen the developed world reach new heights, with little sign that far greater heights won't be exceeded before the turn of the 22nd. Novum Engineering believes in the potential of utilizing cutting-edge technologies to realize the future-proofed infrastructure necessary to support this continual societal growth in a way that can be sustained far into the future. New ground is being broken that will propel the UK forward on a number of fronts, whilst easing the stress on existing infrastructure assets. Magnetically levitated, individually powered train cars travelling in a tube subjected to near vacuum or Hyperloop technology is an incredibly efficient mode of transport. A mode of transport, until now, only envisioned on a scale suitable for passenger use. Not only is it efficient, it's fast. Novum Engineering has integrated this technology into London Gateway Port on a scale capable of transporting two 20-foot shipping containers between London and the proposed Hyperloop distribution hub in Birmingham at a rate of 8 containers every 3 minutes and reaching the hub in less than half an hour, a journey that would otherwise take 3 hours by road. Novum Engineering has cornered the market on the future of freight transport here in the UK. Starting with London to Birmingham, Novum Engineering envisions a Hyperloop network spanning the length and breadth of the UK, access to which will dramatically increase the container throughput potential of London Gateway. Currently, road and rail networks are over-relied upon to move cargo inland, leading to increasingly congested highways and high levels of pollution. With this new Hyperloop line in place, countless inefficient diesel-powered lorries will no longer be needed on UK highways, having a measurable reduction in the amount of carbon associated with the import-export industry. The London Gateway 2.0 project takes new technologies, innovations and future-proof designs to ensure the highest cost efficiency for the future of the port. Currently, the largest container ships, ULCVs, can carry 21,000 TEUs, which is expected to increase to 25,000 within the lifespan of the port. Novum Engineering has undertaken a conceptual design to predict the characteristics of such a ship, and has designed the new port terminal accordingly. The existing quay wall will be extended by 1.3 kilometers and will be designed to accommodate a range of vessel sizes up to this concept vessel. The world's largest robotic ship-to-shore cranes on the quayside will load and unload containers to the container carriers below. All container movement in the port will be automated using optical character recognition and automated guided vehicles, AGVs, increasing efficiency and safety by limiting human interaction. AGVs will take the container from the ship-to-shore crane and move them to their allocated container stack for storage and distribution. Automated gantry cranes using the same technology will organise the placement and picking of containers in each stack. For freight destined for transport via Hyperloop, a dedicated container stack will be used for pre-storing containers before being moved into the terminal. The terminal building houses 2 airlock systems to access the Hyperloop network, which will send the freight in specially designed pods. These pods will take 2 TEUs and can travel at speeds upwards of 300 miles per hour to the central Birmingham hub, whilst a maintenance area for the pods helps keep the system running smoothly. The terminal building also houses the main control offices for the Hyperloop system and port operations, as well as the ship-to-shore crane control and over 1 square kilometre of premium office space for leasing. Any TEUs being received by the port through the Hyperloop network will return to the container stack in the reverse pattern to loading. Though Hyperloop will dramatically reduce the requirement for traditional transport methods, road and rail will still be largely active on the port. From the north edge of the container yard, AGVs will transfer containers to HGVs and to freight trains. This extra zone of automation means human activity is limited to only the HGV area, train line and custom offices. North of the train line lies the distribution and logistics warehouses. This area provides the necessary space for various industries to have readily available access to the port facilities. Roads and roundabouts have been optimised for HGV turning and maintaining traffic flow. A site-wide sustainable drainage system will manage 33,000 cubic metres of surface water, providing flood alleviation as well as limiting ground pollution and enhancing the site environment. Within the northern parcel, 3 highly efficient 2 megawatt wind turbines will produce 20.1 gigawatt hours of clean electricity, feeding directly into the port supply and into the local distribution network, to provide power for local residences and businesses.
The Hyperloop terminal building accommodates all of the mechanical and electrical equipment and machinery required to monitor and operate the Hyperloop transportation system. Designed for robustness, longevity, and aesthetics, the structure has a sturdy, reinforced concrete frame with large, clear spans and tall columns supporting its expansive roof, reserved entirely for solar panels. Its monolithic construction and vertical, reinforced concrete wind girders provide the structure with ample lateral stability. The structure has 3 gantry cranes, one for loading containers into pods, another for unloading them, and a final crane servicing the maintenance area and capable of lifting pods into and out of the basement for repair. An airlock system has been implemented to allow the pod to exit and enter the Hyperloop tube without losing the near vacuum within the tube. Each airlock has 2 airlock doors, and each door has been designed to withstand a low-speed impact, adding safety to the system. To move the pod from the inbound to outbound track, the pod must be rotated by 180 degrees. This was accomplished through an off-center turntable. The turntable allows the pod to be rotated and translated in one process, removing the need for a turn in the track within the terminal. The pod was designed to house 2 20-foot containers end to end and utilizes the same levitation method which is planned for the Hyperloop, in duct track. This will provide a low-energy method of achieving near frictionless movement throughout the journey to Birmingham. The structure also features an attached steel-framed office building, laterally braced by the concrete frame of the adjacent terminal building. The office building not only features modern office space, but the control centre for the Hyperloop and automated port systems. A workshop, various staff facilities and visitors centre provide comfortable working conditions for staff, as well as opportunities to promote Hyperloop technology and the all-new London Gateway. Efficiency and future-proof designs are the key aspects of London Gateway 2.0. Fully automated portside facilities ensure efficient, reliable 24/7 port operations. Electric automated guided vehicles in the form of flat-top container carriers and straddle carriers will be used to move TEUs between the container stacks and associated mode of transport. The AGV's battery levels are monitored by the control room and are automatically sent for recharging at a threshold level. All AGVs, gantry cranes and ship-to-shore cranes use optical character recognition technology to identify each container. This information is fed into a control system which allocates the storage location on the port and its destined mode of transport. The quay wall has been designed with the future in mind. Larger and more capacious ULCVs are enabling ever greater efficiency in container transport. A future-proof steel combi-pile quay wall has been designed to withstand the large loadings seen during berthing and mooring of these supermassive vessels. In addition, the world's largest ship-to-shore cranes will be used to ensure adequate reach and height is available to suitably accommodate the ULCVs of the future. All fenders and bollards are designed to protect the quay wall from these ships, whilst permitting berthing by the smaller ships predicted on the port, ensuring continuous sustainable operations for all vessels.
Novum Engineering is a newly established engineering consultancy specializing in the integration of the Hyperloop system in infrastructure. Novum Engineering is made up of 9 key engineers with backgrounds in mechanical, civil, and marine engineering. As project manager, it was my responsibility to keep the project on schedule and to manage the team. Our director, Jack, guided the project scope and vision, as well as the company image, while supporting me with aspects of management. We were both assisted by a project auditor, James Bubb, who managed project documentation. The rest of the team consisted of specialized engineers and consultants who facilitated the design of London Gateway 2.0. Our engineering team consisted of James Bubb, who was also our maritime structures engineer, Aram, our logistics engineer, Will, our principal mechanical engineer, James Torr, our consultant naval architect, Robert Mackley, our civil and infrastructure engineer, and Robert Wilkinson, our renewable energy consultant. All designs and sketches produced by the team were handed to Elliot Tam, our drafting engineer, who compiled the designs to produce a 3D model and renders.
Each stakeholder of London Gateway 2.0 plays a vital part in determining both its direction and its success. Novum Engineering put the needs and desires of those stakeholders at the heart of each design decision in order to maximise the project's positive impact on the UK. This can be seen throughout the design of our Hyperloop terminal building, its positioning and orientation chosen to best avoid disruption to the site and nearby towns, its premium office space available to high-interest stakeholders, or in its visitor centre, which is open to the general public and offers views of the port and the Hyperloop terminal's inner workings. Each deliverable of London Gateway 2.0 was designed to limit disruption to the existing port operations whilst remaining fully integrated, benefiting both DP World as well as the various logistics companies already invested in the port's success. A SWOT analysis has been conducted to identify the company's current advantages and challenges. The main strengths that Novum Engineering possesses is the company's clear vision to integrate innovative advanced technology with primary infrastructure assets and the variety of engineering disciplines the organization harnesses. Novum Engineering is a young, emerging company with great ambition, however the organization lacks experience running a business as well as large-scale projects. Being involved in a remarkable and innovative project gives Novum Engineering the opportunity to shine and to be recognised as the UK's leading Hyperloop integration specialists. Our major threat is a lack of investment in this, our maiden project. However, we are confident that our vision and business plan will engage potential investors. Each of London Gateway 2.0's deliverables are designed to the latest standards and specifications where applicable, ensuring each one is fully capable of delivering on its promised function both safely and efficiently for the entirety of its design lifetime. As the project enters the construction phase, preparations will be undertaken to enable well-managed construction operations. Temporary site offices will be set up in the centre of the reclaimed port area away from construction. Once construction of the infrastructure has been completed in the northern parcel, the 3 wind turbine foundations will be poured and the towers erected. Within the same construction period, the AVG charging and maintenance sheds will start construction on the east side of the container yard. After a year of construction, the Hyperloop terminal and quay wall will be finished and ready for testing and handover. The completion of the wind turbines and AGV sheds will follow closely a few months later. Once the infrastructure in the northern parcel is complete, the temporary site offices will be relocated to within the Hyperloop terminal. Finally, the container yard and portside area will be paved and all plant and offices removed from site. Upon completion, the site will be tested prior to handover. Prior to site mobilisation, Novum Engineering forecasts a required cash injection of 51 million, with further investments of 190 million and 147 million needed before construction and deliverable handover respectively. In total, the forecast cost for the completion of London Gateway 2.0 is 357 million. The Hyperloop system has the capacity to transfer 1,920 containers every day, and with the cost of £120 per journey, the system will provide a net annual income of 51 million. With the income provided, the project is set to break even 10 years after handover and provide a net surplus yearly profit of approximately 39 million within the following 40 years. London Gateway 2.0 is set to deliver the future of freight transport here in the UK and bring new levels of efficiency to an industry built upon efficient operation. Alongside some of DP World's existing systems and infrastructure, our innovative Hyperloop terminal, future-proof quay wall, intelligent automated logistics system, modernised supporting infrastructure, and use of renewable energy technologies make up the world's most advanced container port, offering tangible benefits to the environment and the UK's economy. Hyperloop is the future of both passenger and freight transport. Here at Novum Engineering, we're making sure that the future is no longer just an exciting concept, but well on its way to becoming reality.